Okay, so it's time to get started. Couple notes. Again, if you are having any questions during the live stream, feel free to send me a message via Edsby, via email, or via the live stream chat. And again, if it's outside the live stream, you can send me questions via Edsby or email. Today, we're looking at the multiplication of polynomials and solving equations. So we're going to take up some questions from both those sections, go a little quicker through the multiplication, and then spend maybe a little more time on solving equations. Again, these are concepts we've kind of discussed throughout the year, so hopefully it's not a huge transition into the material. So I've selected a few questions to take a look at that I feel are good ones we can take up. So we're going to start with question number 3. And we're going to look at 3a and 3e. So 3a is we're multiplying a number by a binomial. And again, binomial means there's two terms there, the 5x and the plus 2. They're separated by a plus sign. And if you're separated by a plus or minus sign, that means that you have a binomial. When there's two terms, trinomial would be 3 terms separated by pluses and minus signs. So we have what's called a monomial times a binomial. So if we take a look at multiplying this one here, oops, sorry, wrong. There we go. What we have here is 3 times 5x plus 2. And we have to multiply everything inside the brackets by the number outside the brackets. So we have to multiply 3 times 5x, and we have to multiply 3 times 2. So we have to do 2 multiplications here. When we're multiplying the number letter portions, we just multiply numbers by numbers, letters by letters. So in this case, we have 3 times 5, which is 15. And then the x doesn't have anything to multiply, so we just leave it there as just x. So we have 15x. So if there's a letter involved, we just leave it there unless there's another letter to multiply it by. And then the second multiplication is 3 times the plus 2. So you treat that as a positive 2. And we have 3 times positive 2 is positive 6. So we put down positive 6. I know sometimes when we use the term positive 6, we don't put the plus sign in front of it. But when you're multiplying these equations out, you've got to put the plus sign there, or in the case of a negative, the minus sign. Otherwise, you just have 15x6. And if we had that, if I got rid of that positive sign, 15x6, well, when there's nothing in between, we need to multiply. But that's not the case. This is something that was added together. So when you have a positive 6, positive answer, you put the plus sign in there. And again, same thing, when it's negative, you put a negative sign in. So using that same procedure on the next one, in this case we have negative 3x as the monomial, and our binomial we're multiplying it by is 2x plus 4. So we have to multiply 2x by the 3x, negative 3x, and then we also have to multiply the 4 by the negative 3x. So again, everything inside that brackets gets multiplied by the term outside. So numbers by numbers, and then letters if there are multiple letters get combined. So we start with negative 3 times 2. Negative times a positive, it's going to give us a negative. 3 times 2 is 6. And now we worry about the letter part. We have x times x. And again, recall, when you have that, x times x, we can simplify that and write x squared. So that's what that x times x becomes. It's x squared. And then finally, we have negative 3x times 4. And so we have negative 3 times positive 4. That's going to give us negative 12. And then there's still an x there. That has to be multiplied in. So it's just negative 12 times x. That's our solution to that. Negative 6x squared minus 12x. So again, the key thing here with these multiplication questions is that we're multiplying everything inside the brackets by everything outside the brackets. Numbers get multiplied by numbers, letters get multiplied by letters. Good idea. Draw these lines. I do it a lot of times myself, even though a lot of times I do it in my head that way. I make sure I multiplied everything, especially when they get to longer questions, like we'll see when we get to number 5. The next question we'll look at here is number 4. In the case of number 4, we have a rectangular picture frame, has dimensions that can be represented by 2x centimeters and x minus 3 centimeters. We want to write an algebraic equation to represent the area of the frame, and then we just want to expand that equation. So here I've drawn a frame. Doesn't look, it looks a little more square, but again, doesn't matter, it's just a diagram. But again, we have one length of 2x, and then the other side length is x minus 3. When we're calculating area, it's the length times the width. So we're just going to multiply 2x by x minus 3. So I have 2x times the x minus 3. And again, we don't have to put a multiplication sign in there because when two things are side by side with no sign, it's assumed it's multiplication. And now it's just the same type of question as we did in number 3. We're going to multiply 2x by x, and then we're going to multiply the 2x by the negative 3, and that's going to expand the equation. So when you're asked to expand the expression, what you're doing there is just multiplying when you're to expand something. So when you do that, we have 2 times the 1x there, so that's just a 2, and then x times x simplifies down to x squared. Then we have 2 times negative 3, that's going to give us negative 6, and then there's an x there. Only old x gets put down there again by himself. So 2x squared minus 6x is the expanded form, so that's part A, that's part B. Want to take a look at number 5, where we had a bit of a longer one in question B. So in question B, we have 4w times 3w squared plus 6w minus 8. And so same rules apply here. We're going to multiply everything inside the brackets by everything outside the brackets, in this case the 4w. So we're going to do 4w times 3w squared. We're going to do 4w times positive 6w, and we're going to do 4w times negative 8. So that's 3 multiplications we have to do here. So the first one, 4w times 3w squared. 4 times 3 is 12. And then I have w times w squared. So remember, w squared is w times w. And so we have w times w is the w squared times the other w. So I have 2 w's from here and a third w from here. So I got w, 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 or w to the power of 3. In the next part, I have 4 times 6, positive 6, which is positive 24. And then w times w will make w squared. And then in the last part, we have negative 8 times 4, which is negative 32. And then again, we have the w there that we have to put down. So even if we have 3 terms, if we have 4 terms, if we had 27 terms in that bracket, all you're doing is multiplying each term individually by that term on the outside. The next question to take a look at here was number 7. In the case of number 7, it's a little bit more of a word problem. So you have an internet company plans to extend into a rural area. The number of customers they will gain can be modeled by 3m times 12m plus 20, where m is the number of months after they expand into the rural area. So this is actually a common application of math, is that we actually look for ways to model real-world situations so we can make estimates on which is this even a viable option. Maybe this company uses this model to determine, will we make enough money to even expand into that rural area, or will we actually lose money because it'll cost to put in new infrastructure. So we often use math in these equations to do this type of modeling. In our case here, we're just working on simplifying that, and then we're going to calculate using that original expression, the number of customers they gain after 6 months, and then use our simplified expression from A to determine the number of customers they gain after 6 months, and then see which version we prefer. And that one would be more of an opinion type of question. So if we do that, I have the initial question here written down. We want to simplify that, and to simplify that, we have to expand it. So simplify means that when you have a multiplication with brackets, we want to expand that multiplication. So we're going to do that same concept as before. We're going to multiply 3m by 12m, and then we're going to multiply 3m by 20. So 3m times 12m is going to give us 36m squared, and then 3m times 20 is going to give us 60m. So that's part A. Now the next part, part B, had asked us to determine the number of customers they will gain after 6 months using the original expression, so using this top line here. So in part B, we're going to replace the m's with 6. So 3 times 6 times 12 times 6 plus 20. And now we have to use BEDMAS to solve this. So we do the things that we'll do the things in the brackets first. So 3 times 6, we'll leave that because it's multiplication. And what's in the brackets here? Multiplication first. 12 times 6 is going to give us a total of 72. So we have 72 plus 20 in the brackets equals 3 times 6. And then 72 plus 20, that's going to give us 92. And then I'm just going to do it up here so I can fit it. 3 times 6 times 92, we can do that all together. And 3 times 6 times 92 is going to give us a total of 1,656 new customers. Now, in part C, we want to use the second equation. So we'll do C over here, and we'll have 36, and instead of the m, we're going to write a 6. 36 times 6 squared plus 60 times 6. So again, using BEDMAS, exponents first. So I got 36 times 6 squared, which is 36, plus 60 times 6. Now I can do my multiplication, and I have 36 times 36, which is also 36 squared, and that's 1296, plus 60 times 6, and we're going to get 360. And now we just add those two together. When we add everything up, we get 1,656. Now notice a couple things. One, both our answers are the same, and they should be. This equation and this equation are equal to each other. We just have changed the way they look. So we've just changed the appearance of the equation. We haven't actually changed what the equation is equal to. So these two equations are the same equation. They just are in a different form. This one's not expanded. This one is expanded. But in either case, we get the same result, which is what we're looking for. Now, the part D question was, which one do you prefer to use? Well, really, that would be up to you, whichever one you're more comfortable with. Myself, I think this has got a lot more brackets. It can get a little more confusing because of that. Where here, I feel there's less chance of getting confused because there's fewer brackets. I can do the exponent, then the multiplication, then the addition, and be done with it. So I did it one less step after doing it step by step by step. I like this one a little bit better, but again, your choice as to what you would actually prefer. Unless you're explicitly told to do it one way or another, you can choose your own way. So that's all the questions from the multiplication section. So again, key ideas there is that you're using this expanding by multiplying that first term outside the brackets by each term in the brackets, be it 2 terms, be it 3 terms, be it more terms. So now the next part we want to take a look at is working with solving equations. And so now we're moving on to actually finding the missing values and finding out what those m's and w's and x's and things are. So looking at the next section in the textbook here, we're going to start with question number 2. We're going to take a look at 2b, and then we'll take a look at number 4 as well from that page. So in the case of 2b, we were asked to solve for x. So we need to find out the value for x. Now, there's a couple ways you might do this. You might take a look at this and say, hey, I can do this in my head. X is 6. 5 times 6 is 30, and 30 plus 10 is 40. And a lot of times, you'll be able to do that, calculate it easily in your head, and get the right answer. The problem becomes if you choose that and don't learn the method of how to solve these. What I've seen is students spend 20 minutes on a larger question with larger numbers trying to guess the right answer, and on a test all of a sudden they've spent 20 minutes on one question that really should have taken them a minute or two to complete. So even though we're using some small easy numbers in a lot of these, go through with the process of actually trying to calculate it using the procedure that we use. And so this procedure here, we're going back and thinking of when we were solving some of those Pythagorean theorem questions, and we had a variable on one side with the number, and we had to move it over, the number over. So we're doing the same idea here. We want to do things in the opposite order. So if I think of the order that I would do this in, if I was calculating it, multiplication would come first, and then I add the 10. So we got to do that in the opposite order. I got to deal with the 10 first, and then we'll deal with the multiplication. So the first thing we want to do is deal with this 10 here. So I'm going to rewrite the equation without the 10. And now that 10 that I put in the box, I need to deal with that. Now I got to get rid of this from this side. How do you get rid of this addition? An addition of 10. Well, you do the opposite and you subtract it. So you have 10 minus 10 on this side, and then the plus 5x. And then you have minus 10 on this side as well. 10 minus 10 will become 0. We'll just be left with 5x. And then 40 minus 10 is 30. And so now we're left with 5x equals 30. And we're multiplying x by 5 to get 30. So how do we get rid of multiplication by 5? Well, we have to divide by 5. And so we just divide both of those sides by 5. And in these questions, it's usually easier to write the bar form instead of the division sign. So we can divide those two. We'll cancel each other out. Multiplied by 5 divided by 5 cancels out. We're just left with x. And then we have 30 divided by 5, which would give us 6. So again, when we're looking at these questions, we're looking at the steps that we have to go through. Some of them will be one step, some of them might be 2 or more steps. But we look at, if I was to calculate this, if I knew the number for x, using BEDMAS, I would do 5 times x as my first step, and then I would add 10. So to solve this, I have to do everything in reverse BEDMAS, and thus I deal with the 10 first and subtract it, and then after I've subtracted the 10, I can divide by the 5. In question number 4, what we have is a square with a side length of s. Yes, s. And the perimeter of the square is 28 centimeters. What is the side length of the square? Well, perimeter is 2L plus 2W for our rectangles and squares. It's actually 4L for a square as well, but if you just use the rectangular formula, because we usually treat a square as a rectangle, then what you can do is replace the length, which is going to be s, and the width, which is also going to be s, right? Because it's a square, both sides are the same. Our perimeter is 28, so our perimeter of 28 equals 2 times s plus 2 times s. I've replaced the length and width with the size s, because the length is s and the width is s. Well, 2s plus 2s, that's 4s. So I got 4s on that side, and then still my perimeter of 28. So now how do I get that s by itself? I'm multiplying by 4, so I got to do the opposite of multiplying by 4. I got to divide by 4. And I divide both sides by the 4. These ones will cancel out, and I'll just be left with s. 28 divided by 4 is going to give me 7. So in this case here, our side length is 7 centimeters. And that's it. The next question I had selected to take a look at was number 7. So we'll take a look at number 7 in the textbook here. So number 7 says you buy 6 t-shirts and a $40 or $42 pair of jeans and spend a total of $168. Write an equation to model the situation and then determine the cost of each t-shirt. So when we look at this, we got 6 tees and one $42 pair of jeans that cost $168. So the cost is the total over here. So that's our total. So that's, when we're writing the equation for this, this is going to be replaced with an equal sign. So something is going to equal 168. And then our jeans and our t-shirts equal 168. So this is going to be plus. We're going to be adding those values together because we got to get the total cost. We have 6 t-shirts, but we don't have a dollar value for the t-shirts, so we don't know how much they cost. So it's going to cost T for a t-shirt. We'll say the cost is T for t-shirt, and each t-shirt has a cost of T, so we have 6 of them. So 6 times T will give us the cost of the t-shirts. And our jeans, we know the cost is 42, so we have our dollar value there. And then again, that's our 168. There's our equation. So 6 t-shirts and the $42 pair of jeans cost a total of $168. And that is an 8. So we've written our equation, and now I'm just going to rewrite that a little cleaner down here. 42 equals 168. And now the part B had asked us to solve and determine the cost of each t-shirt. So again, what we need to do is figure out the order of operations and then reverse it. So here we would start and do the multiplication first. So 6 times T plus 42. So to do that in reverse, we would move the 42 plus 42 first and then deal with the 6T. So we have 6T plus 42, and then to get rid of a plus 42, we're going to subtract 42, equals 168, and then whatever you do to one side, you got to do the other to keep it equal. And so now we do 6T on this side, because the 42 minus 42 will cancel, and then 168 minus 42 is going to give us 1, 2, 6, 126. And then to find the cost of the t-shirt, we got to get the T still. We got 6 T's, cost 126. So how do you get rid of the 6 times T? Well, to get rid of times 6, you divide by 6. So divide both sides by 6. These will cancel. You're left with T. 126 divided by 6 is going to leave us with 21. And so our t-shirts cost $21. So again, BEDMAS would say multiply, then add. So to solve this, we have to reverse everything, undo everything. And so we start with the 42, get rid of it by subtracting it from both sides. Then we're left with the 6 to deal with, and it's multiplied by 6, so we divide by 6 on both sides to get our final result. Okay, just a couple more here. In number 8, what we're dealing with is the same type of question is asking us to, or no, this is number 8. Am I doing? Yeah, I'm looking at the wrong section. One sec there. Yeah, so number 8 asks us to solve for b in each case. So I got a couple questions here to take a look at. Now the difference with these questions is we have b here on this side, and we have b here on this side. And so now it changes up what we got to do a little bit. We got to move all the b's to the same side and then get all the numbers to the other side. So let's start with just getting the b's to one side. And eventually, as you get comfortable, you might be able to do this all in multiple of these steps in one. But for now, let's just start, keep it kind of simple. So we're going to get all the b's, and I think putting them all on the left side is a good procedure. So we're going to move this 12b here over to the other side. So how do you get rid of 12b in this question? We got 12b here minus 20. So we're not getting rid of a multiplication or division because the separation here is this minus. We have a positive 12b. To get rid of the positive 12b, we're going to have to subtract 12b. So we're going to subtract 12b from both sides. So we have 10b plus 30 minus 12b equals 12b minus 20, and then again minus 12b. These will cancel. Plus 12b minus 12b cancels out, becomes 0. So we're just left with the minus 20 on this side. And then we have 10b plus 30 minus 12b. Well, if you recall from before, 10b and negative 12b have the same variable. Both have a b, and it's at the same exponent, which is a 1. So we can collect these as like terms. So we have 10 b's minus 12 b's, and we're left with negative 2b, and then the plus 30. Now we're just looking at an equation like we had in the previous examples. And so we would multiply by negative 2, then add the 30. So to reverse it all, we're going to get rid of the plus 30 first. So negative 2b plus 30 minus 30 equals negative 20 minus 30. Those will get rid of each other. We're going to be left with 2b, negative 2b. And be careful, because I said 2b, and I sometimes forget to say the negative sign, but I usually write it. But a lot of times, an error that students make is that they forget to bring that negative sign. And that negative sign has to stay with that 2b the whole time. It can't disappear. It's got to stay until the end. Negative 20 minus 30. It's minus 20 degrees out. It gets 30 degrees colder. It's going to be minus 50. So negative 2b equals negative 50. We're multiplying b by negative 2. So to solve for b, we have to divide by negative 2. So we divide both sides by negative 2. These will cancel. We're just left with b over here. Negative 50 divided by 2. Two negatives will divide to make a positive. 50 divided by 2 is 25. So again, what happened here that made it different in the first step here is that we had the b on either side. So we have to move all the b's to one side so that we can end up solving for that b. And so that's what we did. We moved this 12b over to the other side by subtracting, and then we were able to get to an equation like we had when there's only one variable hanging around that we can solve for. So similar idea with the next question here in part C. We have 7b minus 9 equals 2b plus 6. So we got to get all the b's to one side. So to get rid of this 2b in this addition question, so positive 2b, if we were to subtract 2b, we would be able to get rid of it. So that's what we're going to do. And I shouldn't write that there. I should write on the next line. So we have 7b minus 9, and again we're subtracting 2b from each side, equals 2b plus 6 minus 2b. So we get rid of both the 2b's, because the plus 2b minus 2b, those will cancel each other out. This side we're just left with 6. 7b and negative 2b, again, like terms, both have the same variable, both have the same exponent. 7 minus 2 going to give us a 5b minus 9. And then again, BEDMAS would say multiply b by 5, subtract the 9. So that means we're doing the opposite order. And we're going to get rid of the 9 first. So let's get rid of this 9. 5b minus 9. We would add 9 to get rid of the negative 9. So we add 9 to both sides to keep it equal. These 9s will cancel. We're left with 5b. 6 plus 9 is 15. And then again, we have that multiplication situation where we have 5 times b, so we got to divide by 5 on both sides and get our final answer of 3. b equals 3. That's the bulk of it. The one thing I did want to note is just when you get to a question like number 11, and I had students have an issue with this in some other courses as well. Question number 11, it had us gave us a perimeter of a triangle shown as 40 meters. Write a formula and solve it to determine the value of n. So you'll notice there's this one side length here is 2n plus 3. The problem is sometimes students confuse the meters as variables. So notice that there is generally a space in there, and if we look at the textbook version of it, which might be easier to see, there's a space between the m and the 11, there's a space between the 16 and the m, and there's a space here, even though my textbook version kind of skews that too. What we have is that, again, that's the meters. So we have to be conscious of whether we're looking at a variable m or if we're looking at a measurement, in this case in meters. And so again, in this case, that m means meters. So you're not using that m in the equation. So your equation in this case would be, for the perimeter, 11 plus 16 plus 2n plus times 3. Or sorry, 2n plus 3. So again, that's going to be the equation, 11 plus 16 plus 2n plus 3. There's not going to be an m in that equation because it's not a variable. So other than that, that about covers everything for today. The last section is going to be next week, and that's going to be on substituting to solve equations. Again, not a brand new topic, something we've kind of done throughout the course of the semester, but just a little more review. Again, for those of you watching, if you are interested in, I sent a message out to everybody this morning, but if you're interested in summer school, check the EDSB messages. There is an opportunity to do a half course instead of the full 4 weeks. I think it's 10 days of summer school to do make up for math and Englishes and that. So if you feel that you could use a little extra time in working on the math course, then take a look at that. There's a link to the registration page for summer school. Some of you might find that beneficial, just to make sure that you're keeping up on that, or even if it was something like English that you maybe did first semester last year and are kind of first semester this year, you're kind of forgetting it. You can also take a look at doing an English upgrade, or you can take full credits and get ahead in things like math, English, or careers and civics, I believe, is also another option there at the grade 10 level. Anyways, that's it for this week, guys. Again, if you have questions, send me emails, send me messages on EDSB, and we will see you next week.